What's up, YouTube? Woo! Mr. King coming at you live in the studio. Here's what we're doing today. You're going to calculate the amount of force when a QB is sandwiched. And I don't mean he was given a sandwich. You will see what I mean. Okay. Today, the title is Newton's Second Law Notes. Please have your notebook look like this. Yes, this is Cornell note style. On the left side, have words on the screen. On the right side, give me examples, like a picture. And this is new. I just added it. If you see this star, this asterisk, that means it's very important and I'll help you on the quiz. So that means you need to write it down. Everything else that doesn't have the star, it's okay if you don't have it down on your notes. First thing, I want to do a little review. Remember, inertia means change, resistance to change. So things that are heavier have more inertia. It's harder to move something that's heavy compared to something that's light. Okay? So looking at these two cars, which car is accelerating faster, the light car or the blue car? Yes, you can easily tell which one's going faster, but you can also assume, since they're racing, the light blue car is also going to be accelerating more because it's on a turn. And I know this seems a little weird, but I'm going to tell you a story. Okay? It's a true story. In the 1920s, there was a race to be the first pilot to cross the Atlantic Ocean from the US in New York all the way to Paris, France in Europe. And the prize was $500,000 in today's money. So this company, they felt like people didn't really trust planes. Planes were a new invention, and Americans in particular haven't really embraced planes yet. So there was an American contest to cross the Atlantic Ocean, to be the first one. And once someone did, people felt like they could trust planes a little bit more because they could make all this way. But before, planes kept crashing. And they would crash, but instead of crashing in a field, I couldn't get a picture of a plane crashing in an ocean. But the reason is because the planes were so small. One, they could only carry a few people at most, and the planes weren't designed to hold very much fuel compared to the planes today that can go for hours and hours on end with no problem. These planes, they would sputter out and always crash in the ocean. So many people were losing their lives because they couldn't get across. The planes were running out of gas too fast. But one person in 1927, his name was Charles Lindbergh, he won the prize money and became an international celebrity. And he was forever remembered for being the first one to cross the Atlantic Ocean from New York to Europe. People attribute his success to this wooden chair. Why do you think this chair helped him be the first to make it across? Pause video now. Try and think, why did this chair in particular versus like a metal chair that was really conventional or common at the time, why do you think this chair, people were saying, helped him be successful to make it across? I'll give you a sec. It does have to do with inertia and gas. So, hopefully you realized the less mass, so replacing a lot of things that are heavy with things that are light means less inertia, which will mean that it'll be easier to move the plane with the same amount of gas. So you'll have more acceleration. So you could have been that famous pilot to go down in history because the idea was very simple. He knew that planes were a little bit too heavy and he wanted to cut weight where he could. So to be more conservative with gas. The reason is, the heavier you are, the more gas you need to go the same speed as something that's light. Which is why, like, if you're carpooling with friends, you should charge them for gas money. Because your car will be using more gas the more people that it has. Because it takes more gas to get a car moving that's heavy compared to a car that's light. Okay? So, I have a practice question for you. Let's say if I push, this man's pushing this car, and this kid is pushing this car. Let's say they push them with roughly the same amount of force. Which car will go faster? The one on top, the one on the bottom? Okay? Remember, Lighter, less inertia, easier to move. Heavier, more inertia, harder to move. This car is much heavier. It won't go as fast. And we're going to start using calculations to explain that today. So please write this in your notes. Force is equal to acceleration times mass. And a way to remember it, F equals A times M, or FAM. I don't think people say that much anymore, but that could help you remember FAM. Force equals acceleration times mass. So to figure out how much force something has, he takes how much it's accelerating times how much it weighs. Okay? For example, for a picture, you could think of a bullet could give the same amount of force as a car. Even though a bullet's very small mass, it has very large acceleration, so it can do a lot of damage to your body. And similarly, a car can also do a lot of damage to your body, but that's because it has a lot of mass, less acceleration. So that's just to show you both acceleration and mass are proportional, and if you make the acceleration a lot more, then that'll increase the force. Same with if you make the mass a lot heavier. Okay? I want you to know we did a FET on forces earlier, and the reason why they show the forces with this letter N is because the units for force are newtons, named after Isaac Newton, the guy who discovered gravity. Okay? So on a test, if I ask you what the force is, I want you to put the number in newtons. And this will help you. 1 Newton equals 1 kilogram times meters divided by seconds squared. And try and think, where does a kilogram come from? What does a kilogram mean? It is your mass. We use pounds in the US, but the rest of the world uses kilograms, so that's what we're going to do. Okay? So the kilograms, I want you to make sure the weight is in kilograms. And remember, meters per second squared represents acceleration. Okay? The meters per second squared, the squared part means every second that it's getting faster or slower. Okay. Now, I have a sample problem for you. This will be a good one to do in your notebook. My advice is to write down what you know and what you don't know and draw a picture. Batman and Superman are playing tug of war. Batman weighs 100 kilograms and pulls with a force of 100 newtons to the left. Superman also weighs 100 kilograms and pulls with a force of 500 newtons to the right. You should know Superman's stronger. Okay? The rope weighs 10 kilograms. I added that because it'll help you solve the answer. What is the acceleration of the rope when they're playing tug of war? Okay? Pause the video now. Try and solve it. I will go with answers in a sec. Okay. First thing you need to figure out, which way is the rope going to move and by how many newtons? That'll make it easy so you can figure out your force. So it says Batman is pulling the rope to the left, Superman is pulling the rope to the right. Batman pulls with 100 newtons to the left, Superman's pulling with 500 newtons to the right. Remember from forces earlier, if the left and the right ones cancel out, it doesn't move, but if one of the forces is greater on one side, the rope will move that way. And that is the case here. Superman's pulling stronger, so the rope will go to the right by 400 newtons. So now that you know the rope is moving to the right by 400 newtons, I want you to write down what you know. Fill in the blanks for F, A, and M. And if you don't know what it is, put a question mark, but you should know 2 of the 3 of them. Okay? So remember, Superman is pulling harder by 400 newtons, so we know the force overall, the net force is 400. We don't know the acceleration, because that's what I asked you to figure out. And we do know the mass. Superman is pulling, he's pulling not only Batman's weight, but also the weight of the rope. So you take Batman's weight, 100 kilograms, plus the weight of the rope, 10 kilograms. So he's pulling 110 kilograms with a force of 400 newtons. Now, all you need is to plug into the equation. Force equals mass times acceleration. If you use some algebra, you'll get acceleration is equal to force divided by mass. So you take 400 newtons divided by 110 kilograms, and you'll get 3.6 meters per second squared. And that's how you solve it. That's how much the rope is going to be moving every second that they play tug of war. Okay, I have a new problem for you. This one is related to football and has to do with our objective. Okay, I'm going to show you a little clip. Ooh, ouch. Okay, we're going to find out how much force that was. All right, Richard Sherman collides with the quarterback Andy Dolphin. Richard pushes Andy backwards with a force of 55 newtons. Andy is still trying to run forward. However, he does end up going backwards. Andy is accelerating backwards at -5 meters per second squared. That's how much he's going backwards. That's definitely going to hurt. Remember, it's negative because he's going backwards and he's going faster. Andy weighs 80 kilograms. How much force is Andy pushing forward with? So we're trying to figure out how much was Andy pushing forward with while he got hit. So pause the video now and try and figure it out yourself first. You always learn more if you try it yourself and see where you messed up. Okay? Here's my tips though. My tips are draw a picture and find the total force first. So we know at the end Andy's going backwards with a force of 55. Trying to figure out how much is the person pushing. So draw a picture with some arrows to find the total force. And you can use the numbers that I underlined here. So if Andy is accelerating backwards at -5 meters per second squared, and he weighs 80 kilograms. To figure out the force of that at the end, so he's going back 5 meters per second squared, and he weighs 80. The force of that is going to be 80 kilograms times 5 meters per second squared. 80 times 5 is 400. So that's how much he gets knocked back. It's 400. But we know at the end, he's only going backwards with a force of 55 newtons. Okay? So it gets pushed back 400 newtons. So if you drew a picture, here's Andy. He's getting pushed back -400, but we don't know the blue arrow. We want to know how much is he going forward. He's getting pushed back -400. We don't know the blue arrow, but we do know at the end, I told you he goes back with a force of 55 newtons. So we know overall it's 55, but since he's going backwards, it's negative. So the net force is -55. He gets pushed back -400, but we don't know how much he's pushing forward. So you solve for x here. Here's the net, what he gets pushed back. We don't know how much he's pushing forward. So you add the -400 to this side. You get -55 plus 400. That's how much he was pushing forward, 345 newtons. So he didn't get hurt as badly as if he wasn't moving at all. Okay? He was actually pushing a lot forward. It's just that force was enough to knock him way over. Okay? That is how you solve it. Thank you so much, everyone, for staying with me. If you got those both right without my help, you are completely ready for the quiz on Friday. Thank you so much, everyone, for staying with me. Bye.